Okay, so now let's go ahead and do another example. In this one, I'm going to keep the talking, much more limited than I did in the last video because we've already done one. Okay, so in this case, we have a cost function, C of Q equals 7Q cubed minus Q squared plus 3Q plus 16. Now, remember, this is what you need to be doing here is you need to be repeating this. Okay, so after you go through this with the video, shut the video down and then just take these equations and work through the entire thing yourself without looking at the video. That's the ultimate goal, because you're going to be tested on this, and these are examples of actual questions I'm going to give you on an exam. So we have a cost function that looks like this. Now recognize that this cost function has not only variable costs, okay, but also has fixed cost, which in this case is equal to 16. So if Q is equal to 0, in other words, if I shut down production, I'm still going to owe 16, okay, for fixed costs. We're going to have a revenue function that equals 3.25Q, okay? Now, again, if you were to identify this, you could immediately identify this as being a perfectly competitive industry type, or purely competitive, as some people say. Why is that? Because marginal revenue is constant. Okay, marginal revenue being the derivative of the revenue function. It's constant, so we know this is a perfectly competitive industry type. Marginal cost. Marginal cost, of course, is the derivative of the total cost function. That is 21Q squared minus 2Q plus 3. Okay. Now, if I asked you to find profit maximizing Q, identify shutdown point, and find profit at Q star, we'll call that Q star as well. Find profit at Q star, we'll actually call that Q star PC. Find profit at Q star PC. If I asked you to find these things and graph them, okay, what's the first thing we need to do? Well, the profit maximizing condition is and always will be where marginal cost equals marginal revenue. That's where the profit maximizing output level is going to be. So the first thing we're going to do is we're going to set marginal revenue equal to marginal cost. That gives us 21Q squared minus 2Q plus 3 equals 3.25. That reduces to 21Q squared minus 2Q minus 0.25 equals 0. Breaking out the quadratic function, we get Q equals 2 plus or minus the square root of 4 minus 4 times A times C, all divided by 2A, which is 42. Now again, recognize, I've mentioned this in several past videos, recognize how I extended that radical sign to cover all the components under the radical. If I stop that short, that would not be proper. That means only part of this would be under the radical. You need to make sure you pay attention to detail when you're doing your mathematics, okay? So what is this now? So this should give us Q star. Okay, and so Q equals 2. We only need the positive amount of this at this point. So that'd give us 2 plus 4. Well, let's break out the old calculator here. So that gives us, oh, I'm low on batteries. Yeah, see, I'm low on batteries. Anyway, this gives us 2 plus square root of 4 minus 4 times 21 times negative 0.25, and that equals 7 divided by 42, which equals 1.66. Okay, so this would be 2 plus 4 minus 4 times 21 times negative 0.25 divided by 42. That's all we're interested in. The profit maximizing output level is the positive value. Again, I'm not going through everything we did in the last video. There's no need to. This Q star sub PC, so the profit maximizing Q for the perfectly competitive firm then equals 0.167. Okay. Now let's start graphing. Okay, because we can. We have enough points now that the graph it actually starts becoming meaningful. Okay, so again, I'm going to put dollar signs on the vertical axis, Q on the horizontal axis. Graphing marginal revenue. Marginal revenue is 3.25. Okay, so that's marginal revenue. We know it's purely competitive, so that would also equal the price and the demand for our product. Okay, make sure you put all those three components in. This is at 3.25. We have a vertical intercept for marginal cost of 3. So that's at 3. We have an intersection of marginal revenue and marginal cost of 0.167. So we know that this marginal cost function comes down and goes like this. Now, what do we need to find? So that, we found that, okay? Circle that, okay? Because that's part of our solution. And that's part of what I want to see when you're doing your math on the exam. So circle that. Okay, next thing we need to do is identify the shutdown point. Now the shutdown point is going to be characterized by the minimum of the average variable cost curve, okay? And I need to graph that as well. So what is average variable cost? What is variable cost? It is this portion of the total cost function. The portion that's a function of Q. That's total variable cost. So average variable cost is that divided by Q. Okay, so average variable cost as a function of Q equals 7Q cubed minus Q squared plus 3Q, all that over Q. Well, this equals 7Q squared minus Q plus 3. Okay, so that's average variable cost. Now we need to graph that. Okay, so here's what we need to find the lowest point on that curve. Now we see that already that it's got a vertical intercept. Let me move that paper up. That it's got a vertical intercept of 3. So it's going to come out of the same part of the vertical axis that the marginal cost curve came out of. The second thing we need to know is we know it has to cross marginal cost at some point by definition, and if it does that, it's going to have to come back up through marginal revenue at some point. So let's go ahead and find that intersection with marginal revenue. So we're going to set this equal to marginal revenue. That equals 3.25. Okay, so this gives us 7q squared minus q minus 0.25 equals 0. Okay, now question is, what is q? Okay, so what is that point over here? And we're going to find that out using the quadratic formula again. So in this case, q equals 1 plus or minus the square root of 1 minus 4 times 7 times negative 0.25, all divided by 14. Now again, we need the positive value of that. So, breaking out the trusty calculator again, okay, we get 1 plus square root of 1 minus 4 times, excuse me, let me go back, minus 4 times 7 times 0.25 negative 0.25. That equals 3.828 divided by 14 equals 0.273. Okay, so that equals 0.273. That means somewhere out here, that is where the intersection of average variable cost with marginal revenue is going to be. So now, if that's the case, so average variable cost is going to look something like this. I keep writing this wrong. I don't know why I keep thinking marginal cost. Average variable cost. So that's what the average variable cost function looks like. Now, that said, how do we find the bottom of this? Okay, well, again, we can do one of two things. We can either look for the intersection of marginal cost and average variable cost, or we can simply find the symmetric value of Q for average variable cost, which is going to be somewhere over here because average variable cost has to come back up. So what is the negative value of Q? Well, let's break out. That's the easiest thing to do, right? Because we've already calculated the positive value. Just calculate the negative value now. So we get 1 minus the square root of 1 minus 4 times negative 0.25 equals divided by 14 equals. So this average variable cost function comes back up here at a Q equal to negative 0.13. Right, so we're going to put that down here. Q equals negative 0.13. Okay, so now we're going to find, since that's our symmetric point, we're going to find the middle of that. We're going to find that point right there, which should be in between this intersection and that intersection. What does that give us? That gives us, let's see, 0.273 plus 0.13 equals, then we're going to take that and we're going to divide it by 2. That equals 0.201. So now I'm going to take 0.273 and I'm going to subtract that, the answer, subtract from that the answer, and that gives us 0.0715. So this is at a Q equal to 0.0715, okay? 0.0715. Is that the shutdown point? No, that is the Q corresponding to the shutdown point. The shutdown point is the price below which, if it falls, the firm has to shut down in the short run. So the shutdown point is actually this vertical point that corresponds to this Q. How do we find that? We take that value, plug it back into our average variable cost function, which is this, and calculate it. Okay, so that gives us AVC at 0.0715 equals 7 times 0.0715 squared minus 0.0715 plus 3. And what does that equal? Well, again, breaking out our trusty calculator, we get 7 times 0.0715 squared minus 0.0715 plus 3. 2.96. Okay, so we have identified our shutdown point. Okay, so we've done two of these. We've taken care of 2 of the 3 items the question is asking for. Okay, so this is our shutdown point. We identify that as the SDP, shutdown point. Okay, this, we identify that as Q star PC. Okay, so that's done. Okay, so we got this, and we got this. Okay. Next thing we need to do is profits at Q star PC. So we don't have a profit function yet, but we can make one, right? Because we have revenues and we have costs. So profit equals total revenue, which is 3.25Q, minus total cost. Now remember, you got to switch these signs here because we're subtracting total cost. So that this minus sign here gets distributed through this equation. So that is 3.25Q minus 7Q cubed plus Q squared minus 3Q minus 16. Now, so that's our profit function. We can simplify this a little bit by combining like terms to negative 7Q cubed plus Q squared. Okay, now that's negative 3Q plus 3.25Q gives us plus 0.25Q minus 16. This is our combined and simplified profit function. So then profit at the profit maximizing output level, which is 0.167, equals negative 7 times 0.167 cubed plus 0.167 squared plus 0.25 times 0.167 minus 16. And putting all this mess into our trusty calculator, we get negative 7 times 0.167 raised to the 3. That term plus 0.167 squared. Now that term plus 0.25 times 0.167. Now that minus 16 equals, so profit at 0.167 equals negative 15.96. Okay? In other words, our profit is negative. Our profit is negative. Now this begs the question, which I'm not going to ask you on an exam, but if profit's negative, does this company stay in business or not in the long run if this profit is sustained, if this loss is sustained? Well, not in the long run, but in the short run, they do keep operating. Number one, we can see that the price is 3.25. The shutdown point is at 2.96. So obviously they're going to keep operating in the short run. But furthermore, in absolute value, their loss is less than the fixed cost. Okay? The fixed cost is 16, but their loss is negative 15.96. In other words, they're making enough money to cover all their variable costs plus a little bit of fixed cost. And they can continue to operate in the short run like that. Can't continue to operate in the long run, but can continue to operate in the short